Hi, my name is Patnode. I'm the Director of Solutions Integration for Emerson. And in the past 37 years with Emerson, I've had various roles, but currently I support system-level innovation related to cold chain activities in order to help our customers drive higher value. And today, I'm thrilled to be here as part of the NASRC Sustainable Refrigeration Summit. And my topic will be Emerson CO2 Solutions, investments that we've made in CO2, and total cost of energy studies I wanted to touch on that's top of mind for many retailers. You know, as I was putting this presentation together, I was going through the NASRC annual report and looking at their objectives, and really a lot of the objectives that they had align themselves with some of the topics that I'll be talking about, whether that's driving higher performance, ensuring service readiness, training perspective related to natural refrigerants, or working on areas to try to achieve cost parity, lowering costs, trying to figure things out. So today I'm going to try to talk about CO2 compression. So only what has been updated recently. There's a couple things I want to touch on. I also want to touch on CO2 controls. There's some things that you may not be aware of that's happening in our design, development, and testing that I'll bring you up to date. And then CO2 training. What are we using for training? What do we have plans for? And then talk about additional transcritical booster lab capabilities that we're going to have here in the U.S., which I'm really excited about, and talk some more about some lab investments and a total cost of energy study that I think many of you will be interested in what's going on in that space and where we're at. So this image obviously is a transcritical booster system, fairly basic one, but with the use of parallel compression. And our transcritical semi-hermetic products, of course, are rated for parallel compression use. I'll be talking a little bit later about specialized controls for CO2. But now I just want to focus on a few things related to semi-hermetic transcritical and subcritical scroll compression. So from the transcritical compression perspective, number one, our largest displacement compressor, the 4MTLS 28ME. We've got 9 displacements in our lineup. And you can see from the 40 down on the bottom left here, that's about 40,000 BTUs at plus 20, 45,000, all the way up to the new one will give us about 310,000 BTUs at plus 20. And I'm excited about that for this launch at the end of this year, because it'll give us opportunity to get those to be in that large commercial light industrial space, because you can need less compression to do the work. So that's really important. The other thing that's very important is the fact that all of those 9 displacements are now approved for 70 hertz operation. And I know that in some cases when you're at peak capacity demand, you want to be able to overspeed that compressor a bit to meet those capacities instead of adding a larger compressor. So we have the ability to do that now. And application engineering bulletins are being completed. Width reduction program, that's interesting as well, is we're reducing the width, the overall width of the compressor by 17 to 23%. That'll be completed at the end of 21. And that really gives the OEMs flexibility on the rack size. When you have 4, 5, 6 of these things on a rack, you can cut down the size of the rack. So that's an important consideration. On the subcritical scroll perspective, we launched a digital 58 model. So we have 6 displacements already in subcritical scrolls from about 21,000 at minus 30 Fahrenheit rating point all the way to 104,000. We have a digital version, which means that it has capacity modulation capabilities down to 10% of that 104. We had a 34,000 digital. We've just added middle of the range 58, which gives, again, designer flexibility in meeting capacity requirements as system conditions change. And we also have semi-hermetic low-temp compressors rated 135 bar, really up to 140,000 BTUs. Plus, the last thing I want to mention is we're increasing our stocking levels here at our Mount Comfort, Indiana location, and that's good news for OEMs when they're given short lead times to build racks. So that's the compression side. On the control side, I'm very excited about this because the industry needs a control that is simplified, has integrated CO2 native features built in, and can really help contractors in the field. And that's why I'm excited about the Lumina E3 CO2. The E3 is actually a rack control facility management system that is replacing our legacy E2, which there's about 250 CO2 systems running with the E2. But now the new E3 CO2 will have embedded native CO2 applications like the integrated high pressure and bypass control, gas cooler, flash tank control. We'll have simplified setups, troubleshooting features with it. We'll integrate parallel compression, adiabatic gas cooling, and all of the high-end strategies part of that. So it's a lot easier to set up, not only for the contractor in the field, but working with OEMs to simplify line setups as well. So that's a big deal. And we're completing the parallel compression testing at our Helix Innovation Center, where we have a transcritical booster system. And the results we're getting are amazing, transitioning in and out of transcritical or supercritical mode with the parallel compression. So we're thrilled about that and excited that these features are being layered in through 2021. Other product that we're very excited about is a new next level CC200 case control, which not only has Modbus communication, but has BACnet IP. So you can actually communicate directly to the cloud from the case if you choose to do so. And so customers have been asking for that direct IP functionality. And so we've added all types of features to this case control. We've got expansion modules that can do up to 3 expansion valves on the one case control, whether they're pulse width modulated, whether they're stepper, as well as an electronic EPR as part of that loop. We've got touchscreen display that can sit at the case, plus mobile applications. So we've got all the flexibilities and the features that our customers have been asking for. And for all refrigerants, including CO2, later this year in 2021. From a CO2 training perspective, I mean, this is near and dear to my heart. When I started doing CO2 business development with Emerson back in 2014, our first trainer was completed in 2015. This is a 3rd generation hands-on mobile training unit that gets shipped around North America. And prior to COVID, it had a North American tour, a few stops in California, New York, and Florida. But we want to amp that up, of course, coming out of the pandemic, having a unit that can be dedicated to the U.S. market. So we're working on that, plus training sessions online that are being developed now. This is a fully functional, you can walk 360 degrees around it. There's DX evaporators for low temp, DX for medium temp. You've got your low temp, you've got your boosting feature. Plus there's a dry ice function in here as well that customers can actually see the formation of dry ice by just dropping the pressure super fast with our compressors and having the refrigerant turn to dry ice and then watching it sublimate and turn back to a fluid. So really cool training unit that we want to amp up the training. We're also adding some functionality to our software, our product selection software, as well as new software development that are in the works for OEMs. So we're thrilled about that. Natural refrigerant lab, something that we already have a Transcritical CO2 lab at our Helix Innovation Center. But we're adding an additional facility, Transcritical Lab in Sydney, Ohio, plus a condensing unit test facility. Now, I know that NASRC did a survey about 6 months ago talking about the need and for CO2 condensing units. Well, we need to understand that from our own perspective so we can help support our customers as they build these out. So that's why we're doing it. That's why we're building this Transcritical Booster Lab in Sydney, Ohio. This has got all the functionality of a real supermarket. It's got parallel compressors, medium temp, low temp, even a low temp with a split suction. We'll have the ability to do adiabatic gas cooling, dry gas cooling, heat reclaim, and even false load 100% of the system with gas cooling, false load, or have everything on display cases and walk-in coolers in combination thereof. So we have complete flexibility to be able to manage the dynamics of the system. Plus the fact that our low temp cases are all equipped with dual defrosting, electric and hot gas defrost, to understand those dynamics. And so it's a unique opportunity for us to learn, for us to collaborate with industry to make sure that we can improve the performance and try to drive costs down and cost of ownership down when it comes to CO2, not only for booster systems, but as I mentioned, also condensing unit application, single condensing unit application. So a lot going on in that space, and of course, a lot will continue to happen. Now, cases, we've got about 2,500 square feet, Sydney, Ohio, and there's going to be 18 different display cases, low temp, medium temp, island, plus a walk-in cooler and a walk-in freezer will not be in this area, but will be tied to the particular rack. And as I mentioned, we'll have full case redundancy by false loading as well as this active management. So that's going to give you a snapshot for the Transcritical Booster Lab. But it's all part of a bigger picture. Emerson investing $100 million in the Sydney facility in Ohio. And part of that investment is labs. We're redoing all of our labs in the middle centralized the building, which really can improve on safety of our employees, improving on light. You can see on the left, there's a lot of natural light coming in. Because the labs are close to each other, interaction between the technicians, the engineers, the scientists that are working in those labs will be in close collaboration with each other. So there's a lot of positives to pulling all those labs into one area, including labs that are already existing, like sound and vibration labs and material engineering, power electronic labs. Those are all adders beyond even what we have here. So we're pretty excited about that and the addition of the CO2 facilities that I've talked about. And finally, I want to touch on total cost of ownership study. This is something I've heard NASRC talk about, and I've seen them report on different things. And it's not like we're trying to compete with others. But when you do your own study, you get to understand it much better, the ins and outs of what you had to go through, and to give you a better appreciation, a better appreciation for how to help our customers and how to collaborate more with industry. So we've worked with Cushing-Turrell to come up with basically 8 full system designs. You can see on the left, and I'll cover them on the next slide a bit more, but each one of those design architectures has these specifications on the right. 25,000 square feet, 450,000 medium temp with 14 cases and 5 coolers, about 90,000 low temp, 7 cases, 1 freezer. They prepared refrigeration schedules for each architecture, electrical schedules, floor plans, refrigeration floor plans, electrical floor plans. We've done LCCP analysis for 4 climate zones on all of those architectures. And we really need to understand that total cost component. We're working with OEM partners on equipment costs, with contracting partners on understanding what the installation costs, commissioning, service maintenance contracts would be on each one of those for those different climate zones, so we can get a better appreciation for what that really means. So the architectures we're talking about, I mentioned 8 different architectures. Centralized, top left here is our baseline 448, 449. Transcritical booster, adiabatic gas cooling, of course, electronic valve, and hybrid cascade system using 448, 449 on the top. Distributed scroll packs, micro-distributed using R290 water-cooled, single condensing units, scroll booster with medium temp racks, and these two are pretty close to the same. This has a combination of 2 or 3 compressors, all handling the low temp loads. And the one here on the right, again, is a low pressure for medium temp or low temp, but the low temps have individual compressors on each case, which also allows them to be dual temp, medium and low temp, gives them that flexibility. So those are the main 8 architectures. Like I said, we've done all the refrigeration schedules, all the floor plans, plus we've we're doing the LCPP analysis where these are the 4 climate zones that we've chosen. We weren't going to do all of them, but these are representative. So warm climate, zone 2, Houston, Bakersfield, California, Dayton, Ohio, and Minneapolis. And kind of gives you an idea. This is just happens to be the annual CO2 emissions, CO2 booster with adiabatic, of course, you would think is the lowest, and it is. So those are things that we're working on right now. We're just finalizing the results of the maintenance and commissioning, and we plan on presenting our findings this fall. So thank you once again for this time. I'm really thrilled to have been able to participate in this refrigeration summit. Thank you.